The camshaft position sensor, or CPS, monitors the camshaft's rotational position, providing crucial timing data for fuel injection, ignition, and valve operation. It ensures the engine control unit, or ECU, knows the exact position of the camshaft for optimal engine performance. Without it, your car won't run or run poorly. A bad camshaft position sensor can cause several issues. Look out for engine misfires or rough idling due to incorrect timing. The check engine light may illuminate, often with codes like P0340 or P0344. You might experience no start conditions, reduced power or stalling in severe cases, and increased emissions due to inefficient combustion. These symptoms can mimic other engine problems, so proper diagnosis is key. CPS failures typically stem from mechanical wear, especially in older engines with vibration or oil sludge buildup. Electrical issues like corroded connectors, damaged wiring, or electromagnetic interference can also cause problems. Oil leaks or coolant seepage can degrade the sensor itself. While less common, manufacturing defects in low-cost sensors can also lead to failure. Begin troubleshooting by using an OBD2 scanner to check for diagnostic trouble codes. Focus on codes like P0340, which indicates a camshaft position sensor circuit malfunction, or P0344, which signals an intermittent sensor issue. These codes provide a starting point for diagnosing the problem. Step 2. Visual inspection. Carefully inspect the CPS wiring and connectors for signs of corrosion, damage, or loose connections. Clean any corroded terminals using appropriate cleaning tools to restore proper electrical contact. Repair or replace damaged wiring to ensure reliable sensor operation. Finally, ensure the sensor is securely mounted and free from physical damage. Step 3 involves using a multimeter to test the camshaft position sensor's voltage and resistance. Set your multimeter to DC voltage mode and connect the leads to the sensor's power and ground terminals. The voltage reading should typically be between 5 and 12 volts when the engine is running. For resistance testing, switch to ohms mode and measure between the signal and ground terminals. Magnetic-type sensors often show 500 to 1200 ohms, but always check your vehicle's specific specifications. Compare your readings to the manufacturer's specifications. This table shows typical values for temperature sensors, but similar principles apply to position sensors. Here's an example of map sensor specifications for reference. Abnormal readings outside the normal range indicate a faulty sensor that needs replacement. Multimeters can also test for non-contact voltage, as shown here with weak and strong signals. Use this feature carefully around electrical components. For a more in-depth analysis, use an oscilloscope to check the signal waveform from the camshaft position sensor. An oscilloscope is a diagnostic tool that displays electrical signals over time, allowing you to visualize the CPS output. Connect the oscilloscope probes to the CPS signal wire and a good ground point on the engine. Set the time base to capture the signal frequency, typically matching the camshaft rotation speed. A functioning CPS produces a consistent square wave pattern with regular pulses corresponding to each camshaft tooth or notch. The waveform should have sharp rising and falling edges with stable amplitude. Erratic signals, missing pulses, or distorted waveforms indicate problems like sensor failure, wiring issues, or electromagnetic interference. Intermittent issues may only appear under specific engine conditions. While this method requires more expertise and specialized equipment, it can pinpoint intermittent issues that basic tests might miss, making it valuable for complex diagnostics. If the camshaft position sensor fails the previous tests, replace it with a new one. Locate the CPS on the engine, usually near the camshaft. Disconnect the electrical connector, remove the old sensor using the correct tools, and install the new sensor, ensuring proper torque to avoid damage. Next, clear the diagnostic trouble codes using an OBD2 scanner. Connect the scanner to the vehicle's OBD2 port and follow the menu to clear codes, which resets the check engine light. Perform a road test to confirm the issue is resolved. Drive the vehicle at various speeds, including highway and city conditions, and check for smooth engine operation, no stalling, and ensure the check engine light remains off. Monitor for any recurring symptoms or error codes over the next 100 to 200 miles. Regular oil changes are crucial to prevent future CPS failures caused by oil contamination, which can degrade the sensor over time.